Okay, we will start now. So hello everybody. Uh, we are starting our webinar about robots and ChatGPT and how these two cool things, two cool technologies combined can be a great superpower for a company. So what we are doing recently for I think 3 or 4 months, we are creating super assistants for different business tasks using these two technologies. Um, what we will talk about? First of all, we will talk about how to ground artificial intelligence in real business using software robots. There is a challenge because everybody heard of ChatGPT, but it is one thing to learn how to use it for your own business processes, and the other thing, much more important and much more difficult, how to make all people in your company use ChatGPT to increase effectiveness of the whole company. And human beings are struggling with this because not everybody adopt this technology easily. Not everybody knows how to make good prompts, and nobody really wants to adopt new technology. So we need some way to scale this thing up inside companies to really boost productivity of all workers, of all employees, regardless whether they personally be using ChatGPT or they won't be using it. So software robots can be a solution of such a problem. For those of us who might not faced with software robots before, not quite aware of RPA, we will talk just a bit about what RPA is, robotic process automation, and we will talk about it on the example of our own platform, Sherpa RPA. Then we will cover a lot of, I think, more than 10 different use cases, real projects that combined these two technologies, RPA and ChatGPT, in real projects of our company that were made in last 3 months. Yes, there will be very interesting tasks, like tasks for tenders for bidders, tasks for sellers on marketplaces, lead generation tasks, marketing tasks, uh, tasks for accounting, for audit, for logistics, for HR, for recruitment, for blogging, for document processing, and a lot more. And we will talk about several of them in some depth, yes, in detail. Also, for those of you who are very familiar both with RPA and ChatGPT, but might not yet look at how these two technologies can be combined together in real world, in real projects, we will cover a bit of technical stuff. If you're unaware with some of the technical terms of technical points we were speaking of, then no problem. You can just skip these and look into business cases. And as I told, there will be enough of business cases. But for those of you, yeah, who wants to know how to really implement this and use this in your practice, we will cover some of technical stuff. And then there will be some implementation advice from us. So we did it. We did it a lot of times, and we can advise you on how to really make this work for your company, for your business, for your tasks. So let's start from the simple idea. Robots and ChatGPT are really stronger together, and we can call ChatGPT to be brain and RPA, robotic process automation, to be some hands. So hands without brain can do only very simple stuff or determined stuff. Brain without hands, ChatGPT without somebody to go and execute this knowledge can maybe write content, yes, answer questions, but only when user asks it to do so. So without human asking, ChatGPT will do nothing for your company. And when we combine these technologies, ChatGPT and RPA, we get benefit when the company will do the robots and the ChatGPT will do everything on their own without any need of intervention from human. One disclaimer here. When I talk about ChatGPT, I use this because it's quite established brand, well known, everybody knows what it is. But I really do not mean exactly ChatGPT. I mean any of the large language models that do exist now, and there are plenty of them because we have Claude, we have from Anthropic, we have other models from OpenAI, not only ChatGPT. We have open source models like Llama, Alpaca, Vicuna, and so on. There are a lot of them. And I will be talking about ChatGPT just for ease, yes, and just because everybody knows what it is. But in fact, every time we mention ChatGPT, I really will be talking about any type of large language model that do exist. And we also have cases when we use it not ChatGPT exactly, but use other large language models that can be used inside closed environment of an enterprise. So with no internet access, where everything is done inside enterprise. And that's also a quite popular case. When we're talking about RPA technology, robotic process automation, basically it focuses on routine processes, on repetitive processes that can be described using some steps, step 1, step 2, step 3, and which humans do every day, every week. It takes a long of time, and those types of processes exist in procurement, in sales, in accounting, in HR, virtually everybody where people sit in front of computer and do some stuff using their monitor, their keyboard, their mouse. And using virtual employees, robots, software robots, we can scale up this process. We can make it much faster than making this process by humans. And by some reports from Gartner, from Forrester, there are up to 70% of such office processes that are routine, that are repetitive tasks, and they really can be solved not by humans, but by software robots, by RPA technology. So this was the state of art in the market by last year, yes. But then there are still some processes, a lot of processes, which still require human involvement, yes, which still require some hard reasoning, some thinking, yes, inside the process. And then we used something which is called man in the loop. When robot does something, then it passes the control of process back to human. Human makes some important decision, then it passes the control back to robot, and robot continue the business process. This is how it worked recently, 1 year ago, for example. But then ChatGPT appeared, the technology that not really can only write content, but it can think the same way the typical human, the typical employee thinks in these different processes. And then when we combined RPA with ChatGPT, with large language models, the amount of processes that can be automated this way, they raised from 70% of all office processes to 90% of all office processes, just because we added ChatGPT into this equation. I think this will be one of the main ideas of this webinar. Who am I, who we are? Yes, a bit of words about us. So I'm the head of Sherpa RPA Global, and Sherpa RPA is the hyper-automation platform which combines traditional robotic automation, robotic process automation solutions. It also combines orchestration, chatbots, some artificial intelligence, machine learning stuff and technologies. It has process discovery inside. It has OCR, IDP, NLP, so intelligent document recognition, intelligent document understanding. And this platform can automate a lot of different business processes inside a company using all of these components. This is a full cycle platform. It allows creating robotic processes in no-code or low-code fashion. So it supports flowcharts. It supports no-code inclusions, low-code inclusions like on C#, Visual Basic, PowerShell, Python. It consists of the visual designer, which allows you to create robotic process, the robots themselves that execute them, the orchestrator, which controls all the robots that you use inside your company, and the process discovery tool that will help you to identify new business processes for automation in your company. Some numbers just to make impression of what our platform really did before. So we have about, yes, over, not about, but over 1 million of work hours saved in last year, yes. And we have about 350 clients from small to medium enterprises. And it is important to notice that about 100 of these clients transferred to our platforms from some other pay platforms. And we have about 5,000 robots deployed within our clients so far. The core of our platform is a user-friendly, citizen developer-friendly designer where you can draw your business process with blocks, with arrows connecting the blocks, and once your plans run, this flow will be executed. So the robot will do everything that is outlined here instead of human. Open some browsers, open some applications, click on buttons, enter texts, copy, paste, send emails, fill in forms, and so on and so forth. And we have more than 500 of ready-made blocks which can compose this flow chart. They include everything working with desktop applications, with browser applications, with Office software like Word, Excel, Outlook, Exchange Server, with SAP, with Oracle, with Odoo, and a lot of others. It can work with messengers, it can work with internet protocols directly, it can work with OCR, so recognizing document context from photos, from scans, and so on. So a lot of different possibilities to automate your business processes. You can also develop your own blocks to automate your business processes, and you can make more than 500 actually. One of the palettes with blocks called NLP and large language models. So you see there are blocks named prompt GPT model, prompt ChatGPT, tokenizer, get embeddings, search embeddings. Those are the main blocks which are now involved in very intellectual scripts for intellectual processes of automation that can do much more than RPA robots could do a year ago. We also use some traditional machine learning, which can be run not in cloud, but on the computer of user itself. We can train and use prediction models, classification models, clustering models, anomaly detection models. We can use chatbots, intellectual chatbots, and so on. And one more question, one more word about intellectual document processing, because by our statistics and by statistics of our partners, up to 30% of all business processes that are automated with RPA platform, they involve working with scans or photos of different documents. So it's very important that platform can recognize these documents. So we have built in OCR, NLP, ML, and IDP model, which can recognize invoices, recognize checks, recognize any types of documents with QR codes, with barcodes, with signatures, and it allows to fill all those details into your ERP systems and CRM systems. And most of this functionality is available offline and built into robot. So you do not to pay more for this functionality. It is already included. We have very powerful templating engine to create smart templates for recognition of some complex documents with tables, with attributes, with anchors. And now we also have a magic button which will draw such type of template automatically for you. So you show one new document never seen before, and artificial intelligence creates the template, yes, for this type of document, which will fit this sample of document and all other samples of the same type of document. So there are some examples of templating invoices, of templating some other types of documents, and you can do this with any type of document actually. So there are a lot of tasks that can be solved by combining robots and artificial intelligence, and more specifically by combining robots and ChatGPT. I will not read everything that is written here because there are typical jobs done by robots before, but each of these types of jobs contains some small or large intellectual part that usually in before days were managed by human, but now we can get all of this process done by robot without involving human. But there are specific tasks that 2 or 3 years ago, nobody of us would give to robot at all because it's too intellectual, yes, too difficult to create some determined business process, determined automation to really make this task happen without errors and with all different possibilities how the outside world can react. Yes, so a lot of cases. And now with ChatGPT, with large language models, we really can give this to robots because robots now can do this type of intellectual tasks. One of these common tasks is answering questions and making decisions based on internal data of a company. For example, think of asking your robot about how much some company owes us under the contract. This question seems to be quite simple, but in reality, for you to answer this question, you need to go into 3 or 4 different systems in 3 or 4 different types of documents, get some facts, gather some numbers, combine them together, make decision, and then you can get the answer because you need to search for an agreement with this company. You need to search for the company itself in some ERP system. We need to search for invoices that you generated. You need to go to bank account and search for outstanding or incoming balances. You need to combine everything, and you need to give one short but factual answer that really answers the question of human. So you need it to be precise. And what now we can do, we can address to both structured data and unstructured data, which is contained inside the company, and then process all this data and get this short answer for this question. Yes, the answer is short, but the amount of data, amount of steps which were involved to give us this short answer are quite huge. What types of data it can be? For structured data, it can be your tables from ERP system. It can be your accounting balances, your bank account balances, yes, the content of your invoices. What unstructured data it can be? It can be the text of agreements, where you say how often company should pay you, what are the payment terms, what are the agreement termination terms, and so on. Yes, that can be your internal knowledge base, which outlines in which cases you should process this situation in this way or in that way. It can be some internal data about how you typically deal with this kind of question of problem. And after examining all this structured and unstructured data, we can give this type of answer. This is what robot now can do for us. How does it work? I'm sorry, now a bit of technical stuff. Yes, if you are from business side, you can skip this, no problems. We will return to business cases just in a minute or two. But for those of you who are from technical side, I think it's worth to mention some technical details about how this really works. So when you get some question, you should understand some context of this question and context of the answer. First of all, you take your documents, your agreements, your knowledge base articles, everything you have about important to answer this question, and you index this into embeddings database. And when I tell you that to index it, I mean that we should break these amounts of unstructured data in some small parts, and we should convert each of these small parts or chunks into vectors, yes, into a number of numbers actually. And those vectors, which are called embeddings, will replace the letters, yeah, the words inside these sections with their meaning, which is transferred into numbers. We all know that the same type of information, the same type of question can be formulated a lot of different ways. Because we are human beings, we are not robots. Yes, we can ask the same question a lot of different ways. So after all, what we need to understand, we need to search for is not particular words in our question, but we need to search for meanings that stay in background of these words, the meanings of these words, the meanings of these sessions, and transferring words into embeddings allows us to search for meanings of these words. So once we indexed these embeddings, we now can construct some prompt, the part of our question, the part of instructions to large language model, and then we can extract relevant parts of our embeddings database by the vector proximity to the question asked. And then we have the several parts of data extracted. It can be three parts, three sections of data that are most similar to our question. It can be five. After all, we look into the lens of context that is available in our large language model request. For example, ChatGPT, it was 4,000 of tokens, about 16,000 of symbols, but now it's much more, yes, with modern versions. So we formulate our prompt with some preamble, with the original question, and with chunks of data that we pre-extracted from our database with embeddings based of vector proximity. And then large language model gives us answer based not on hallucination, not on something that it learned during its education phase, but on our documents, on our databases, on the data we give it before answer. So this is how it works typically. There are much more complex frameworks or prompt engineering techniques that involve embeddings and involve some types of observations, self-prompting, and so on. One of these frameworks called React. I will not describe in very large detail how it works because it's just one of possible techniques, and we have demos that show how to create it inside Sherpa RPA. If you are interested, feel free to ask in my LinkedIn, and I will send you the demo so you can play with it yourself. But there are about 15 different frameworks, techniques that are used now in this automated reasoning when we combine ChatGPT with RPA technologies. And React and one of the most famous frameworks that allows large language model really to think about question and give right answers without hallucination. In Sherpa RPA, there is a demo project which is called Chat with Your Documents. It shows you how you can implement in very simple way this approach with embeddings, with vector similarity search, and with prompt injection, prompt engineering to get answer on the on any data that is contained within your documents. It contains of two projects. One project is called Create Embeddings, and the other project is called Search Embeddings. So first of all, you get some data you want to search inside or get answers from. For this example, we used a user manual for some car, PID car actually. And what Create Embeddings project does, it cuts this document into small chunks, then get embeddings for each of these chunks, and save this into some database. For simplicity, we use just a CSV file. And search embeddings, it asks user for a question about some data contained in this document. Then it gets embeddings of this question. Then it searches the vector similarity, the most similar chunks from our database, which we created earlier. And then it combines it with initial prompt to get the right answer to the user. I think we just can switch from the lines to real project. I will run it, and you will see how it really works. So this is a Sherpa RPA designer, and I have search embeddings project opened here. Yes, we can just run it, and we will see. Doesn't it? So I see this small window where I can enter some questions. So I want to ask something about my car. Yes, because it's a car manual which is inside my database. So I will ask like at what speed does collision warning detector works. So I think that this type of information contains inside car manual. Yes. So I click OK. So there this process will search, and we have the answer. So the collision warning detector works at speeds between 30 and 140 kilometers per hour. So it seems to be right answer. And I can show you what was really indexed. Yes, so here is a Create Embeddings project, and it was PDF file, but for simplicity, we converted it to TXT. It's just the contents of the whole car manual, and somewhere there are answers to our questions. Maybe not exactly how we asked it, but in some other wording. But what is important is that we need project to get the chapters, yes, the pieces of text which possibly or likely contain data for the correct answer. So how do we do that? When we run Create Embeddings, we get this CSV file as a result. We can open it in Excel and just see it. So there are two columns. One column contains our chunks. So this is a pieces of text that we got when we cut our long PDF, yes, long text document in these small pieces, yes. And at the right column, the column called embeddings, we see a lot of numbers. They're floating point numbers. Actually, for each row, I think we have about 1,500 numbers. Yes, because we have such dimension of vector. And these numbers actually represent not the wording of these paragraphs, but the meaning of these paragraphs. And this is very important. So we can later have our question converted into the same set of numbers, the same vector, and then search within all these vectors for a similarity. We will not have exact match to our question, no way. So their probability of this is very low, but we will have some close match, yes, and we can extract, say, 3 top matching paragraphs to a question, of 5 top matching paragraphs. Say it can be this paragraph and this paragraph and then this paragraph. So then we will combine it together and ask our ChatGPT to answer user's question based only on the contents of these paragraphs. So we do this in our next project, which is now open. Yes, here we load our database from CSV file. We show text message to the user. Yes, and if the question is if it exists, yes, if its length is not 0, we get embeddings for this query. Then we search embeddings for our database content in CSV. We extract 5 most close results, and then we combine them into a single string using this loop. And then we prompt our GPT model with this question. And I can really show you the question itself. One moment, please. I'm searching for it. Here it is. So here is what we ask our GPT model. So answer the question using only knowledge-based list below. Then we list the question from user, and then we list knowledge base. Those are the paragraphs extracted from the document. And this is how this robot will find the exact data needed to give us the exact number. Then we just show it to our user. So this is very simple project. Usually when we create ChatGPT and RPA-based automation, the projects are much more complex, but this embedding trick is in core of most of the projects we done with ChatGPT and RPA recently. So it's very important. Let's move further. A bit more complex task. Let it be sales consultant robot. So it will advise buyers in Telegram or in LinkedIn or in Facebook, and it doesn't really matter in which messenger platform or social network it will communicate with user. But we can choose anyone. So let it be a subject area online smartphone store. So we'll ask this consultant about how to get best smartphone. And there are basically 2 different types of questions we could ask. First of all, we could ask about some general questions about this online store at all, about delivery, about payments, about returns, about policies, and so on. And second type of questions we can ask about particular goods which are sold on this particular store, about pricing, about availability, about some technical details, technical characteristics. For example, we can ask to recommend a smartphone which has 2 cameras and which has the amount of battery not less than 5,000 milliamperes per hour, and which is priced below $500 in this particular store. And our sales consultant really should answer us about this. And the next question, for example, we can ask about how can I pay you? Can I pay you with Visa card? Can I pay you with PayPal? And the next question can be about how many days can I use it before I return it maximum? What is the process of returning it? Then I can switch to some other good, like search for the case for my new smartphone, and our consultant should answer all these types of questions. And also, what is more important, it should remember the previous history of communication. So if we, for example, ask about which the best smartphone with 2 cameras, and we get answer to this question, then the user can ask next time what is its price. So it will not mention the name of exact smartphone. It will address it which is its price, because he assumes that the consultant remembers everything that was told off in previous communication. And we should also save this history and use it in each of our next answer. So how we will do that? We will use 2 different data sources. One data source is online stored database with features and prices. And for simplicity, let it be Excel format. Of course, it can be any database which we can address via SQL expression. It doesn't matter really. But for simplicity, it would be just Excel file. And second data source is some seller's instructions. So if it would be not robot but human, he would follow some document which outlines how he should answer to different typical questions. What are the policies of this exact store? So we will give this type of seller's handbook to our robot. So the robot can use information contained in this handbook to answer to the questions of buyer properly. This is an architecture of such a solution. So the client, in this case, it asks consultant via Telegram bot. And we have one ChatGPT based communication agent that which main task is route the question in the right way. So he should understand either we're asking about something contained in our database of goods available, or we ask about some policies. And in one case, we will pass this question to merchandising agent. So we have 3 agent system here. Yes, and the merchandising agent will search for the details in our Excel database or in some other database, extract proper columns and proper rows, and then rephrase answer to the question based on the data extracted. If the user asks about the general policy of this shop, then communication agent will pass this question to knowledge agent, and he will go to a Word document or PDF document which contains some shop rules in plain text, just unstructured data. He will extract the needed data, which is similar to the question user asked using embeddings, the same technique that we discussed a bit just recently. Yes, and it will return with the appropriate pieces from the shop rows, and then communication agent will formulate the correct answer to the client. So this is how this is usually done. I will not show you the project itself, but if you're interested, you can ask me after the webinar, and I can send you the source code, the sources for this robotic project. No problems. So just to give you impression about which types of tasks can ChatGPT with RPA solve, this is what we did in 3 recent months. Just a quick words about each of these positions. So we created robot to generate a placement on blogs of SEO articles on a given topics. So we get ideas for new posts from RSS subscriptions, then rephrase them via prompt engineering, and then automatically post new articles on blogs. And all these articles are already search engine optimized for a given keywords. Then we created a product card generator for Amazon and eBay. And if you use any of the online marketplaces, you know that there is a text description of a good, and there is like a table with some technical details like characteristics and the values of these characteristics. And when you get information from wholesale, yes, from your sourcing, they can miss some of these. For example, they can provide you only this textual description of good, but do not show you any characteristics of the good. Or they can provide you with characteristics, but there will be no textual description. Or they can contradict so textual description can contradict technical description. So what this project does, it restores missing stats, missing descriptions, reconstructs it from the amount of data available for the product, and it creates other content for this product card, so it could be properly placed on marketplaces. And more important, all this content is for search. So the more details you provide for marketplace, the more probability that somebody who searches for such type of product, he will really find this product from you. So this is why we created this robot for our client. So then we created robot lawyer who answered to legal questions that was more specifically about taxation, based on first of all from on the legal knowledge base of the company itself. And in cases when this robot can't find appropriate answer in the legal knowledge base of the company itself, it will go to some publicly available and commercial knowledge bases like Bloomberg and search there. And then he will combine information that he found in several places to provide user with exact answer to his question. Then we did robot that classifies and routes of calls of technical support and does automatic responses to popular requests. And if this robot can't find answer to the question of client, he will reroute this question to the appropriate technical staff, to the humans who really can answer the question of this user. Then we did social selling robot for LinkedIn. So you know, there are a lot of robots for LinkedIn. It's and there is nothing fancy in it, yes, but all these robots, they just do some prescribed step of actions, connect everybody, write the same messages to everybody, and those, they look very spammy. They have very low conversion rates. It is much better when we answer or write first message to people based on what is written in their profile. So we always find some hook, some interesting fact from the person's biography, from what the person wrote himself recently, and then we send our connection request with some crafted part of data extracted from his own profile, and this makes the chances that we will get reply and that reply is positive. It makes such chances a lot higher. So that's not just another LinkedIn robot. This is intellectual LinkedIn robot. Yes. So then we did some archiving stuff, document processing stuff. We extracted a lot of data contained in scans of contracts. We need that was rental contracts, and the client wanted to have a database of legal form of the lease and contact information and some other types like leasing terms, leasing periods, and he wanted to extract some particular structured information from a structured source. Yes, because all of these contracts were just pictures, yes, scanned PDFs. So we converted these into text, and then we search for the particular facts, extracted them from the documents, and formed a database of these leasing contracts. And of course, quite an important part of this job was done by ChatGPT. Then we did a promo service for a marketing agency. We generated personalized go-to-market strategy based on complete startup profile. So marketing agency used this robot like a teaser, yes, to attract new clients for his services. Yes, then we created robot who did procurement analysis for tenders for bidding, yes, for the bidding documentation. And supplier wanted to understand if he really need to bid this or that tender, if he has ability to complete the tender requirements, to classify this tender based on some checklists. So they're typically a list of 30, maybe 40 different questions that a human bidder asks himself when he reads tender documentation to decide whether we really should bid this or we should skip this, yes, for some reason. So this is a lot of work, and our client, it took about 1 hour to examine each of the tenders. Yes, we need to decide to bid or not to bid. And the robot did most of the job of this bidder automatically. Then we did bot assistant for a crypto exchanger. So we can call this sales bot actually, because this bot was used to attracting clients. He was searching some channels, some chats, public chats, for questions when one users ask other users about how they can make cash withdrawal or cash currency conversions in the country of visit. And then our robot wrote to such a user. So firstly, it identified the intent for cash withdrawal or for currency conversion. And once some message from this flow of messages was identified to contain needed intent, then the robot wrote to this user in personal message like a real human and offered him services for this cryptocurrency exchange platform. And this way he attracted new clients. So this just several examples of what kinds of tasks we did using RPA and ChatGPT. And what's, I think, most interesting that a year ago, if we got such requests from our clients, we would say to most of them that no, it's impossible to do with robot, or well, it is possible to do with robot, but it is lots of work, and there will be a lot of errors, and you definitely need human in the loop to control the results at each stage of this process. But now with ChatGPT, most of these use cases, most of these robots were done the way that they are complete autopilot, so they do not involve asking humans at all. They can do all the process automatically. Yes, I have several slides left. Some of these cases are described a bit in depth, yes, about robots for Amazon and eBay, but actually I already told you about how it works and what problem it solves and how it does it. Robot to win tenders, yes, routing and auto replies to emails, weekly sales and inventory forecast. So that's really cool examples of how ChatGPT can help robots to achieve these smart, intelligent, and complex tasks. So we are close to our end slide. So actually, this end slide. If you have any questions, feel free to contact us, subscribe to our LinkedIn page, send us email. We are glad to ask all your business questions about how to use robots and ChatGPT in your in accomplishing your business task. And if you are a RPA professional, if you are head of RPA team, we are also glad to answer technical questions about how to solve this or that task in technical way. Yes, from technical point of view, we can help you with consultancy or do this project for you. So if you have any questions, it's now time to answer them. Please feel free to turn on your microphone and ask any questions you like.